Alright, we'll go over the resettable fuse right now and how to wire that in. This is the resettable fuse. It's got a red holster to it, the little yellow disc, and the blades. It plugs right into the circuit board of the gas furnace, and direct replacement of the automotive 3 or 5 amp fuse. You pull it out and put this in place of it. It's a permanent fuse that resets automatically. It doesn't burn out. It's reused time and time again, and it replaces pretty much all 6 types of low voltage fuses that you'll find for a 40 VA transformer. And the kit comes with all the adapters and everything you need, so one size fits all. This is all you need to stock on your truck. So I'll go ahead and wire this in. Now, on the resettable fuse, you can wire it in to where it will have a direct short. Let me just wire this thing in. Now we'll turn this on, and it's running the contactor relay. Now it can trip the resettable fuse a couple different ways. It can be like traditional type of protection, where when it blows or opens up, it'll stay in a lockout mode to when it'll still be protecting and opening the control voltage circuit until the service tech gets there to locate the short. It can be wired in to do that. I'll demonstrate that. Every time that we want a short, we want to do it on this side over here. You see the yellow wire coming out, goes through the resettable fuse protection in series, and then we'll power up this contactor relay over here. The relay gets the other side of power it needs straight from the transformer other side. Goes to one side of the coil here, and the other side of the power going through the circuit energizes the other side of the coil. Anytime that you have a 24 volt load like this coil and this contactor, it has to have both sides of the power to energize the coil in order for it to pull this in and work. So we have one side here already. The other side is a yellow wire coming through our circuit and energizing the other side. Now right now we're tripped, and unlike the Short Pro tool, this doesn't have a little LED light to show you that it's tripped and protecting all the circuits. One thing you can do is, if you have your amp probe on, you'll see it's all zeroed out here. There's no current going across there. It's opened up and it's protecting everything. Now one thing it does do is it gets very hot to the touch. You can't even hold on to it. It's about 125 Celsius, so that's very hot. So you can touch it with your finger just to know that, yeah, it is tripped when you get there. And in this case, in order for it to reset, you've got to turn the power off, you know, just for a few seconds or so, and then it resets and you can hear that contactor coil re-engage. Now sometimes you get shorts when you're out there and you can't find it with the Short Pro. That's because it's something called an intermittent short or an inrush. An intermittent short is when two wires will short up against each other just momentary, and then it can separate and not have a short going across it anymore, but that split second it shorted was enough to blow the fuse. When you get there and you can't find it with the Short Pro tool, you put another fuse in there and it starts to work. That's great until that intermittent short happens again. And it could be anything. It could be where some wires or move every so often and touch up in the attic or wall. You got to do a visual and try to find it first. Those are intermittent shorts that happen so often. and it could be in a place you can't get to, is why you can't visually find it. Another type is an inrush, like if you have an electrical storm, or the power goes off in the house from the CPS working on the power, and the power's restored back to the grid. It could have an inrush where it's too much current coming in. And you ever thought why, if these 40 VA transformers that fuse protects, if it's only meant to handle about 1.6 amps, why they have a 3 or 5 amp fuse in that circuit board? Well, it's because it's protecting from those electrical storms, from having those inrushes. It'll draw past that 1.6 amps, and you don't want to keep on going out to a house after every storm to replace a fuse, so they oversize it a little bit. And in this case here, what we can do is wire this inline time delay to it, and I just went ahead and advanced it real quick so it'd come on. And what could happen is, if you have an intermittent short, you can wire this inline time delay in the circuit, and then if you do have a short and it separates, well, it allow this timer to time out and then reconnect that circuit again, so there's not a go back. And I'll demonstrate that. Each time you do a short, you always want to put it where the red wire starts out of this resettable fuse or the short probe tool. You notice the yellow wire coming out goes in to the current protection, and the output is always attached to this red wire going through our circuits. I did it that way just to make sure you create a short with this white jumper. That's the negative side of the power, or the common. And then always touch where that red wire starts right here. You heard that contactor kick in. It timed out on this time delay and reset again. I want you to understand, when you create these shorts, you gotta put both sides of the power together, just like you would a car battery or anything. If you had jumped your car battery before and touched that black and that red clamps that you put on your batteries, you'll see big sparks happen. That's what you're doing here. You're causing a short. And always when you create your short with your jumper, regardless if it's a white jumper wire or red or green, it doesn't make any difference. You attach it to this blue or negative side, and you take it, and you always don't jump it directly to the transformer, yellow wire coming out. It has to be on the output of your protection. I'm going to create a short, and I took or eliminated the short, and it's going to allow this to time out and reset again. The purpose of this is to save the service technician a go back with a very upset customer, because a lot of service techs will guess at where the short is, and they'll replace the wiring going outside. They'll change out circuit boards, thermostats, and it could be an expensive repair. And if you didn't find the short, you hear the contactor kick back in. We got 0.2 amps right here on our current draw. Everything's working fine. The reason I do this is because, if you didn't find the short and you did an expensive repair, that customer is going to be very upset at you and your company. So what you want to do is put the resettable fuse in there, and to make sure you don't have that problem with the customer being upset or having to go back right away. Wire in an inline time delay coming right out of the transformer. Depending on where your fuse is, you definitely want to go through the fuse circuit first, and then you go through your inline time delay. You can wire it in like that, and when it gets that quick short and that short separates or it's eliminated, then that timer will allow it to time out to 30 seconds, a minute. You want to set it for at least 30 seconds, a minute, to allow that to reset, re-engage, and the customers not without the cooling or heating. And it's not until you finally get that short that's going to stay there when you can go out there and troubleshoot it and finally solve it. But until that happens, you have this type of option to do this without having a go back or an upset customer. What I'll do is also, that's about it on this demonstration. I'll probably make a couple of diagrams that we'll take pictures of, and I can show you how this is going to be wired in so you get a better understanding. Thank you.